Hey everyone, today we discuss about gamma function. It is also very important function. So gamma function is a extension of a factorial to a real and complex number. We know factorial of 1. What is factorial? 1 factorial is equal to 1 and 2 factorial is equal to 1 into 2 is equal to 2 and 3 factorial is equal to 1 into 2 into 3 equal to 6. Okay. So we know about factorial, but what is the factorial of 1.5? What is factorial of 1.5 or what is factorial of 1 by 2? So we know the factorial of natural number like 1, 2, 3, etc. But what is the factorial of 1 by 2, 1.5 or 3 by 2, etc.? Is it factorial work for this type of numbers? So a new function is introduced, that is gamma function. It is denoted by a Greek letter gamma of n. Gamma of n. So gamma function is an extension of factorial to real and complex number. We want to know the factorial, about factorial for a real and complex number. So this is a primarily improper integral. Here we are connecting factorial with the integral. So there is a limit. So here there is no definite integral limit, but there is a infinity upper limit. So this is primarily a improper integral, and this is also known as a Euler integral of second kind. Euler integral of second kind. We know the Euler integral of first kind is a beta function. Okay. So we can start with this standard integral. Integral minus infinite to infinity e to the power minus x square dx equal to root pi. This is a standard integral. There is a proof, but the video become very lengthy. So we are starting with this standard integral. Okay. So if you consider this is 0 to infinity, that is half of this minus infinity to infinity. If you are not considering full limit but 0 to infinity, that is a half of this part, then what will be the equation? Then equation is equal to half of the output, that is root pi by 2. Okay. So what is the value of this integral? 0 to infinite e to the power minus tx dx. This is a x into x. If this is in form of tx, that is t is not equal to x, then what is the value of this integral? So we can write this is equal to limit r tends to infinite integral 0 to r e to the power minus tx dx. So if you are applying the limit r tends to infinite, then integrating this function, that is exponential minus tx divided by minus t, applying limit 0 to r. So if you are taking minus 1 by t outside, then we can write it as a exponential minus rt minus exponential minus 0. We are applying the limit. So upper limit minus lower limit. So this also can be write it as a minus 1 by t into 1 by exponential rt minus 1. So here r tends to infinite. So this term will become 1 by infinite, that is 0. Then we can get this equal to minus 1 by t into minus 1, that is 1 by t. So the integral 0 to infinite e to the power minus tx dx is equal to 1 by t. We got a important result. Now differentiate both sides with respect to t. So d by dt with respect to t. So d by dt integral 0 to infinite e to the power minus tx dx is equal to d by dt of 1 by t. So we can, this is differentiating with respect to t, but the integration is with respect to x. So we can take it outside and we can write 0 to infinite, integral 0 to infinite d by dt. This become partial derivative. So dou by dou t e to the power minus tx dx is equal to what is differentiation of 1 by t. This is exactly equal to d by dt of t to the power minus 1, that is minus 1 t to the power minus 1 minus 1, that is minus t to the power minus 2. So we can write it as a 1 by t to the power minus 1 by t square. Okay. So this is equal to 0 to infinite, integral 0 to infinite. Here partial differentiation, that is with respect to t. So this is with respect to t. So we can take x as a constant and t as a vary. So exponential minus dx into minus x dx, that is 0 to infinite minus x into exponential minus dx dx equal to minus 1 by t square. Again we are taking differentiation with respect to t. Zero to infinite dou by dou t of minus x into exponential minus tx dx equal to d by dt of minus t to the power minus 2. Okay. So this is equal to minus 2 into 2. So this is a minus is there, and minus 2 into t to the power minus 3, that is minus minus will cancel. So 2 into t to the power minus 3, that is 2 by t cube. Okay. And if you are considering this side, we are taking a partial differentiation. Here t is varying, x is a constant, then minus x is a constant. Then we can take a partial differentiation, that is exponential minus tx into minus x. That is minus into minus, that is positive. So this become x square into exponential minus dx. Okay. So we will get integral 0 to infinite x square exponential minus dx dx is equal to 2 into divided by t to the power 3. So again repeat the process. We are taking partial differentiation. So we will get 0 to infinity minus x cube e to the power minus dx dx is equal to minus 1 into 2 into 3 divided by t to the power 4. So if you are observing this, here negative sign is a sharp and disappearing alternatively. So here there is no negative, and here negative sign sharp. So negative sign is sharp and disappearing alternatively here. So if you are considering this process into n times, then integral 0 to infinite minus 1 to the power n x to the power n exponential minus dx dx equal to minus 1 to the power n 1 into 2 into etc. n divided by, if you are considering this, we got 3 and the power of t is a 3 plus 1. So if you are applying this n times, we will get t to the power n plus 1. So here this minus 1 to the power n will cancel, and this is equal to, this is a n factorial. So this is equal to n factorial divided by t to the power n plus 1. If you are substituting n plus y equal to, n plus 1 equal to y, then what is n? N is equal to y minus 1. Then integral, we got important result. Okay, so then we applying n plus 1 equal to y, then n equal to y minus 1. then this integral become 0 to infinite x to the power y minus 1 exponential or x to the power minus t into x dx. What is n factorial? Here n equal to y minus 1 factorial divided by t to the power n plus 1 is equal to y. So here we just choose t is equal to 1, t equal to 1. So if t equal to 1, then this integral become integral 0 to infinite x to the power minus y minus 1 exponential minus x dx is equal to y minus 1 factorial, where t is equal to 1, that is 1 power y is equal to 1. So this divided by 1, where t is equal to 1. We are choosing t equal to 1. Okay. So this is a gamma function. This is equal to a gamma of y. So we can write gamma of y is y minus 1 factorial. Okay. So we can rearrange this equation. Gamma of y is equal to y minus 1 factorial is equal to integral 0 to infinite x to the power y minus 1 e to the power minus x dx. So this is a function in terms of y. We can choose any variable like z, n, etc. So if you are taking this y as a n, we can write it as a gamma of n is equal to n minus 1 factorial, not n factorial, but n minus 1 factorial is we define in terms of integral. That is n minus 1 factorial is equal to integral 0 to infinite x to the power n minus 1 exponential minus x dx. So here n should be greater than 0. This is a improper integral, so it become unsolvable for 0 and negative number. So this is a improper integral. So this condition is very important, that is n equal to greater than 0. So this is our gamma function. So what is factorial? So we got factorial in terms of a integral, and we can extend this into real and complex number, but this is a improper integral. So we choose a condition, that is n should be greater than 0. So what is gamma of 1? Gamma of 1 is n minus 1 factorial, that is 1 minus 1 factorial, that is 0 factorial is equal to 1. So what is gamma of 2? Is equal to 2 minus 1 factorial, that is 1 factorial is equal to 1. And what is gamma of 3? Is equal to 3 minus 1 factorial, that is 2 factorial is equal to 1 into 2, that is 2. So what is gamma of n? N is any number, then we can write gamma of n is equal to n minus 1 factorial. And if you are substituting n is equal to n is equal to n plus 1, then gamma of n plus 1 is equal to n plus 1 minus 1, that is n factorial. Okay. So n factorial is equal to gamma of n plus 1, and gamma of n is equal to n minus 1 factorial. I hope everything is alright. We will see in the next video. Okay. Thank you.